Welcome back. So today we're going to be talking about inverse functions. We're in section 5.1. I want to go through a few examples for you. Always be aware that under the modules you can find the 5.1 lecture material, so definitions and things. So always look at those if you're like questioning or wondering what's going on. These are more examples. So here we go. Let's work on number one here. It says find the inverse relation. Now an inverse relation undoes what the relation did. So this relation here takes 4 and it sends it to 5. It takes -7 and sends it to -1. In fact, let me write it like this. So on number one here, if you put an x and an f of x like this, 4 goes to 5, and -7 goes to -1, -5 goes to 9, and 5 goes to -5. Now the inverse relation, it's actually a relation, not a function. So it's a little bit of a misnomer there. The inverse relation reverses this. It takes the output as the input. So if this is y, let me put y over here. If this is y, then y goes here and x goes there, and this is the new input, and this is the new output. It's kind of messed up like that. So it takes a little getting used to. So here we go. So the new input is 5, and it takes you to 4. It reverses it. The new input is -1. It takes you to -7. And the new input is 9, and it takes you to -5. And the new input is -5, and it takes you to +5. So that's what we call the inverse relationship. And technically we would make that x, and we would convert that, make it into a y. And so there's our inverse relation. Now, to write that down, ordered pairs, you just reverse the ordered pairs. Be sure and put the brace. It says type ordered pairs. Oh, the braces are already there. So don't put the brace. The braces are on both ends. So they just want the ordered pairs. So you go 5, 4, comma, -1, comma, -7, comma, 9, comma, -5, comma, -5, comma, +5, and that is the inverse relation. Now the inverse relation, or the inverse function, has a symmetric reflection about a line y equals x. So you're going to see that in this next example here. So on number 2, our function is y equals 4x minus 3. Now, this really is a function. The previous thing may have not. I mean, it actually looks like it was a function, but they were being more generic by calling it a relation. Relation doesn't have as many restrictions. So anyway, this is a function, and we want to find the inverse function. Now here's what you do. You do just like we did in example 1. See how we switched the inputs and the outputs? That's exactly what you do. You make this x, and you make this y. And what we're going to do, now we didn't do this, so you switch the x and the y. You just switch them around. And then you solve for the other variable. So solve for y. So here we go. So solving for y, you get a +3. That's actually the inverse operation of undoing -3, is adding 3. And then the inverse operation of multiplying by 4 is dividing by 4. So we're going to put the 4 over here, and we get y. And there's our inverse function. Our inverse function is 1/4 x plus 3/4. Isn't that different? So if this is the function 4x minus 3, the inverse function is 1/4 x plus 3/4. Look how different that is. So it's a 1 over here, but not the x. The x is up in the numerator. And then it's not just +3, it's actually +3 divided by 4. So be careful there with your inverses. So now we know the function and its inverse. So let's get it on the graph. The line y equals x is the 45-degree line down the middle here, and then we just want to graph these two functions. Let's do the original function in blue. The original function in blue. Let's do a t-chart real fast. we just need a couple values. 0 minus 3, that's pretty important. 0 minus 3. And let's pick another really nice one. How about 4? Sorry, 1/4. No, not 1/4. Sorry, just think about this for a second. How about 3/4? Yeah, let's do 3/4. Now, why did I pick 3/4? Because 4 times 3/4 minus 3 is, well, that's 3 minus 3, which is 0. So it's actually a 0 on this function. So if you plug in 0, you get minus 3. At 3/4, which is right around there, it is 0. Now the graph is so small, it's really hard to see. But the main thing you want to get out is it's really steep. It's a steep function. This is that thing is y equals 4x minus 3. Very steep function. All right. And so to find the inverse function, let's do it in red. Then you just reverse the inputs and outputs. So you get minus 3, 0, and 0, 3/4. All right, we're doing it in red. So if you go to minus 3, we're at 0. So it's that little tick mark right there. Now at 0, we're at 3/4. So we're really close right there. I know it's really tight in that region. Let's see if I can get that red dot going. There we go. And so it's gonna be a reflection. Well, it keeps disappearing. Try one more time. It's gonna be a reflection about that fuchsia line, and it looks just like that. So that this is y equals 1/4 x plus 3/4. All right, I'm going to end that video here, and we'll pick up in just a minute. Thanks.